far as we've been working with our equations and our graphs of circles, we have had the equations in standard form. Standard form is what I often call informally grapher-friendly form because it makes it easy to pick out the center and the radius. So if I've got a circle that's centered at HK of radius R, and definition of the radius, it's positive. Okay, radius is a distance, it can't be negative. All right, then the equation is just x minus h quantity squared plus y minus k quantity squared equals r squared. All right, so for example, if I had x plus 1 squared plus y minus 3 squared equals 16, I can pick out from that very nicely that the center would be at negative 1, 3. Don't forget we've got to change the signs here because the coordinates of the center are the numbers we are subtracting from x and y. And the radius would be the square root of 16, which is 4. Now, I'm capable of doing in my head that the square root of 16 is 4. I like to write that I'm taking the square root of that number because that just reminds me that that's how I get the radius, that I don't just take that number, I have to take its square root. Okay, so that's in standard form. Now there's another form called general form, and that's essentially going to be what I get if I multiply everything out. I'm going to do two things actually. I'm going to multiply everything out and I'm going to move that number over to the other side. So if I did that, x plus 1 squared, I know that means I've got two factors of x plus 1. Remember, exponents do not distribute over addition. I've got to FOIL that out. Similarly, y minus 3 squared means I've got two factors of y minus 3 that I would need to FOIL out, and that equals 16. So if I FOIL this out, I'm going to get x squared. Outsides and insides each give me one copy of x, so that's plus 2x. And then the last terms give me a plus 1. When I FOIL this out, my first terms are y squared. Outsides and insides each give me negative 3y, so that's a total of negative 6y. And then plus 9 equals 16. And what I'm going to do is just rearrange this a little bit. I'm going to put the x squared plus y squared first. So all the second degree terms I write first. Then I'm going to write the plus 2x minus 6y. All the terms of degree 1 I write next. And then I'm just going to consolidate my constants. So on the left I have 1 plus 9 is 10. And I mentioned I was going to move that 16 over. So if I subtract the 16 over to the other side, I'm going to have a total of 10 minus 16 would be minus 6 equals 0. Now that's going to be our general form. So general form, we've got one copy of x squared plus one copy of y squared. Then we're going to have some x's and some y's. So we call that plus a copies of x plus b copies of y. And then plus a number plus c is equal to 0. And of course these numbers a, b, and c are signed numbers. So I wrote plus c. Here I'm looking at c as being negative 6. So adding negative 6 is the same as subtracting 6. Okay, so you can see how we would go from standard form to general form. Just FOIL out the x minus h squared and the y minus k squared and move the constant over to the other side so that you're setting it equal to 0. What I want to take a look at is how do we go from general form to standard form. And we're basically going to do that by completing the square. So essentially, if I had something, let's say I've got x squared plus y squared minus 4x plus 8y minus 2 equals 0. Okay, so that's in the general form for a circle. I'm going to try to complete the square and see if I can get it into this form. And then if I do, and I have a circle, I'm going to try to describe that circle. Okay. So I think the first thing I'm going to do is just rearrange this a little bit. I'm going to put the x's together. So x squared minus 4x. And then I'm going to leave myself some space, plus y squared plus 8y. So there are my y terms. And I'm going to go ahead and just move that number over to the other side, equals 2. Now what I'm hoping to do is complete the square here and complete the square here. Now I'm going to need a number for that. Let me just remind you, if I have x plus a number squared. Now I'm purposely writing it as plus some number that I'm just calling d rather than minus h, because I'm recognizing that d can be positive or negative, h can be positive or negative. It's just easier to work with what I would have if I were adding something. So essentially I'm saying here d is just the opposite of h. Okay. This would be x plus d times x plus d, and when I FOIL that out, that's x squared. Outsides and insides both give me d times x, so I'm getting 2 copies of dx plus d squared. Okay. So what I'm hoping is that these are the first 2 terms of something that looks like that. Now, I'm hoping then to add a number here to complete that square, to add in that constant that would make that into a perfect square. And of course, if I'm going to add that number here, I'm going to add it over to this side as well. So I'm hoping to add in some number here, and I'll add it to this side as well. And then same thing for the y's. I'm hoping to be able to add some number here that would complete the square here to make this a perfect square. And then I would also add that number in here. So I'm going to add the same number to both sides. Now, when we were working with quadratic functions earlier this semester, we also did some completing the square. There, we generally didn't add a number to both sides of the equation because we were looking at functions and we had y by itself was equal to something, and we wanted to keep y by itself to get a formula for that function. So instead of adding the same number to both sides of the equation, we instead added and then subtracted that number on the left side of the equation, or the right side, whichever side we were working with. That's perfectly acceptable. If you prefer to add and subtract this number on the left and add and subtract this number on the left, you can do that, but you're eventually going to move it over to the other side. So I think it's easier in this case when we're working with circles to add the number to both sides of the equation. Okay, so if I look here, I'm trying to make these 3 terms, the 2 that have x's in them that I have, and this unknown number, match this formula. Now if that's going to work, I need to have 1 copy of x squared, and I do. The number of x's that I want to have is 2d. The number of x's that I have is -4. So if I set those equal to each other, that's going to tell me what value of d will make this work. D would equal -2. With that choice of d, these first 2 terms match the first 2 terms for a perfect square. So then d squared would be +4. D squared will always be a positive number, but d could be positive or negative. So I'm going to add in a 4 here, but then I'm going to add a 4 to the right-hand side of the equation as well. And in fact, let me do that in a different color so that it's clear that I'm changing both sides of the equation by adding that 4. Okay, then I want to do the same thing here. Okay, so I'm trying to factor these 3 terms, y squared plus 8y plus some unknown number, trying to make that match this formula, obviously using y's instead of x's. Okay. In order for that to work, I need to have 1 copy of my squared term. Well, I do. The number of, it would be y's instead of x's that I want to have is 2d. Obviously, this choice of D is going to be different from that one, but I'm going to just recycle the name. Okay. The number of y's that I have is 8. So I can solve for D. D would have to be 4. If this is going to match this formula, D has to be 4, but that would make D squared equal to 16. So then I can add 16 to both sides of the equation, like so. And now that we've completed the square, these two things factor. And this should be some of the easiest factoring we ever have to do, because I know this factors as x plus d squared, and I've written down right here that d is negative 2. So this factors as x minus 2 squared, plus this factors as y plus this d squared. This d was 4, so that's y plus 4 squared, equals 2 plus 4 plus 16 is going to equal 22. So now I can see, because I've put this into standard form here, that this is in fact a circle. The center is at 2, negative 4. So remember, when I was completing the square, I was thinking of d as the number I would add to x or y. H and k are the numbers that we're subtracting. So they're just the opposite of those values that we got. Okay. And the radius would be the square root of 22. And I do want to check, but that root does not simplify. There are no perfect squares that divide into 22 that I could factor out. Okay, excellent. So that's how we would go from the general form to the standard form. Okay. Now, will an equation like this always give me a circle? The answer is no. Because when we completed the square here, we were able to get x minus a number squared plus y minus a number squared equals a number. But that number has to represent my radius squared, which means it has to be positive. And so something could go wrong. I could complete the square and I could get 0 or a negative here. There's no way 0 or a negative could be my radius squared. Okay. So that's what we'll take a look at in the next video, what can go wrong if you complete the square. You still get an equation, you just get an equation that doesn't represent a circle. So we'll take a look at that in the next video.